Hello, this is Walker Physics, 4th edition. We're in Chapter 7 on work and kinetic energy, and this is number 28 in the end of the chapter questions. An 1,100 kilogram car coasts on a horizontal road with a speed of 19 meters per second. After crossing an unpaved sandy stretch of road 32 meters long, its speed decreases to 12 meters per second. Was the net work done on the car positive, negative, or zero? Explain. Okay, well, my question is, did it speed up or slow down? If the car sped up, it was because work was done on that car. Okay, if energy was put in that car and that car is getting faster, then positive work was done on it. But if it's getting slower, then what's happened is that there was more friction in the sand than on the pavement. And when the car went into the sand, it slowed the motion down. So friction is always in opposite to direction of motion. So when friction slows something down, that friction is doing negative work on the object, in this case the car. So A would be negative since car slows down. Okay. B, find the magnitude of the average net force on the car in the sandy section. Okay, well, force, remember we're going to do work equals force times distance, and we'll solve for force at the end. So I need to find out what the work was done normally when it was going 19 meters per second. I also need to know what it was when it was slower. And if you remember that the kinetic energy, or the work, either case, is going to equal 1/2 mv squared. So the square of the velocity times the mass. Well, this is the final velocity, and then you'll have to subtract whatever the initial velocity was. Okay, so 1/2 mv squared again with an initial velocity. So we'll start out here with 1/2, and the mass is going to be, what is it, 1,100 times 12, and that'll be squared, and then we'll do it again, 1/2 times 1,100, and then it was originally, this is initial, 19, and it gets squared. Okay. All right, so 11 divided by 2, 1,100 divided by 2 times 12 equals, we have this part as 7,900. Okay, 7,900 or 79,200. That's joules. Do it again. 1,100 divided by 2 times 19 equals, times 19 equals, and we have this is subtracted, 98550. Remember, initially he was going faster, and so this work is going to be negative since it slows it down. So 7,900 minus 198 is going to be a negative number, and that negative number is 119,350 joules. Okay, so we need that, and this goes in the work. And the distance, how far did he go? 32 meters. Okay, so I'm going to divide that into the negative 119. And I get force 3729.7. Looks like two significant figures here. So this is going to be 3,700 newtons. Okay, so that's the force. Remember that force is being exerted backwards. So it's a positive force, but since it's exerted backwards, that's why that it's still, it's a positive force exerted on the car backwards to the way it's going. Okay, that's why that the work would be negative. All right, good question.